They brought back Matlock and made it a lady? Okay. That's weird. Mm-hmm. 25 missing 5, 4, 3, 2, 1. Huh? I don't think so. Okay. Okay, let's get started then. Okay, so this is. Oh, joke. Okay. So this is. Yay. Book 5, Chapter 2, Writing with Output Streams. In this chapter. Oh, Black Goku. In this chapter, we're going to learn about using the insertion operator, working with manipulators, formatting your output, using flags to format your output, specifying a precision for writing numbers, setting field widths, and ensuring data safety with lot streams. Ooh, fun. Years ago, one of us had an old computer that had 3,000 bytes of memory. Yes, that's 3,000 bytes, not 3 megabytes. Ah, straight guy. Underscore official. No, I cannot currently do song requests. This is a C++ All-In For Dummies stream. Hi, Param Prakash Harry. Thank you for the like. Hi, Mofo. Just getting some reading time in. Paul Manager? Oh, yeah. I hear that. Alright. As an option, this computer came with a floppy disk drive that sat outside it. It did not have a hard drive. Therefore, if you didn't have a hard drive, but you wanted to use an application, you had to load the application from a floppy, type its name, and press enter. Ah, those were the days. Nowadays, the notion of a computer without a hard drive seems almost unthinkable. Not only do your applications sit on the hard drive in the form of files, but your applications also create files to store on the hard drive. When you use a word processor, you save your documents to a file. Imagine if every time you needed the same document, you had to retype it. In this chapter, we show you the different ways you can write to a file. Oh, thank you, Mofo, for suggesting people hit the like, and thank you for Prakash Shetari for your very awesome welcoming. Okay. Ooh, inserting with the greater than sign operator. Haley, the only ASMR currently going on is me reading C++ on for Dummies. Oh, thank you, Black Goku. That being said, it's time to show the book. Ah, this is where I'm going to lose a bunch of people. There you go. Code. Yay. Coding time. Yay. All right. Inserting with the less than, I had that wrong. Less than operator. Writing to a file is easy in C++. You're probably already familiar with how you can write to the console by using the cout object. Like this. Cout, then the less than. Hey, I'm on TV. Listen, in line. Next page. Here we go. Well, guess what? The CL object is a file stream. Amazing! And so, if you want to write to a file, you can do it the same way you would with cout. You just use the double less than symbol called the insertion operator like this. Less than, less than. All right. The insertion operator, here in operating the insertion operator, the insertion operator, less than, is an overloaded operator function for the 100% ANSI compliant libraries inside the basic underscore OS stream class, or for the non 100% ANSI libraries inside the OS stream class. You can find several overloaded forms of the less than operator function. Each one provides input for a basic type as well as for some of the standard C++ classes, such as string or one of its base classes. We say or because most libraries that ship with compilers are written by compiler vendors who may implement their code slightly differently but get the same results. Back here, if you open a file for writing by using the OFStream class, you can write to it by using the insertion operator. The file write01 example shown in listing 2-1 demonstrates how to perform this task. All right, listing 2-1. Ooh, ow. Ooh, okay, sorry, stiff. Using code to open a file and write to it, although the dancing time did help. But no dancing time anymore today. That is called last stream. Okay, hashtag include IOStream. Hashtag include upstream. I show it so I don't have to say every little thing. Int main, upstream, outfile.txt. Outfile, lesson, look at me. I'm in a file. Inline. Int x equals 200. Outfile, lesson x, lesson inline, outfile.close, return 0. All right, I can stop showing that. The first line inside the main creates an instance of OStream, passing to it the name of a file called file.txt. We then write to the file, first giving it the string, look at me, I'm in a file. Then a new line, then the integer 200, and finally a new line. And after that, we show the world what good programmers we are by closing our file. Okay, now we're to another aside. This one is called placing data in specific folders. Sometimes you want to place data in a specific common folder, such as the current working directory. The directory, sorry Nightbot, we're done with dancing. Now it's C++ time. The directory used by the application. C++ provides a method to obtain this information. Get CWD with a pair of parentheticals. This method appears in the direct.h header, sandwiched within a pair that is a less than and greater than. So direct.h is sandwiched within a less than and greater than. Using the get CWD opening and closing parentheticals method is relatively straightforward. You create a place to put the information called a buffer, and then ask C++ to provide the information. The get working directory example demonstrates how to perform this task as shown here. Okay, let's see that. Hashtag include IOStream, hashtag include direct.h, hashtag include standard library.h. Using needs to be standard. Int main char current path underscore max underscore path get CWD current path, comma, underscore max underscore path, C out current path, inline, return 0. As output, you should see the name of the directory that contains the application, such as C :/ C plus CPP underscore AIO / book 5 underscore chapter 2 / get working directory. The underscore max underscore path constant is the maximum size that you can make a path. So what this code is saying is to create a char array that is the size of underscore max underscore path, using the resulting buffer to hold the current working directory, which is where the name of the method getCWD comes from. You can then display this directory on screen or use it as part of the path for your output stream. Amazing. Huh? Oh, thank you, Renardina. Okay, next down. Is that something I gotta show? Not for a bit. Okay then. Formatting your output. If you're like us and are receiving lists of numbers to a file, you may find that this process works better if the numbers are formatted in various ways. For example, you may want them all aligned on the right, or you might want your floating point numbers to have a certain number of digits to the right of the decimal point. There are three aspects to setting these formats. There are three aspects to setting these formats. They are format flags. A format flag. Huh? You might have been talking to Nightbot. That's true. Format flags. A format flag is a general style that you want your output to appear in. For example, you may want floating point numbers to appear in scientific mode, or you may want to be able to print the words true and false for Boolean values, rather than their underlying numbers. To do these tasks, you specify format flags. Precision. This refers to how many digits are on the right of the decimal point when you print floating point numbers. Filled with. This refers to how much space the numbers take, both floating point and integer. This feature allows you to align all your numbers. The next three sections discuss each of these in all their glory and grandeur. Remember, you can use the format flags detailed in the upcoming section, as well as precision and with specifiers when writing to your files, and also writing to cout. Because cout is a stream object in the IOStream hierarchy, it accepts the same specifiers as output files. So have at it. Let me check my time. Okay, there's just over 12 minutes left. Formatting with flags. The folks who made the ISO C++ standard gave us a slew of format flags. Remember, if you're using a compiler that includes a library that's not fully ANSI compliant, you will be able to use most of these format flags, but not all of them. Therefore, in this section, we're giving you lists for iOS underscore base for ANSI compliant libraries, and also iOS for non-compliant libraries. What's the difference between C++ and C++? I don't know. I assume this is a joke, and it might have something to do with grades. I don't know, though. To use the following format flags, you call the setF member function for the file object. This could be either your own file object or the cout object. For example, to turn on scientific notation, we would do this. Huh? Nathaniel Magellanes? Oh, it was a great joke. I was thinking, that's a weird question. Are you trying to start a club for racists? Because other than that, I don't know why you would be asking that randomly in chat rooms. No, I'm not interested in a club for racists, because no, I'm not a racist. Oh, hi, Jen's Cooking. It's good to see you again. I'm doing all right. Just doing some C++ on for Dummies time. How are you doing? See out dot sf ios underscore base colon scientific. See out lesson 98765.321 in or if you're using a non-ANSI compliant library, cout.setf ios colon scientific. See out lesson 98765.321 in I'm glad you're well. Oh, club awesome. Thank you, Rainer. Still don't feel like I'm part of the club, but thank you for saying that. Oh, let's see. Oh, thank you, Jen. Oh, let's see. How are things going with your cooking? I was just thinking about you. Might have been yesterday, but it could have been today. Oh, it was today because I was looking at I was going through all of the lives I've done recently that I didn't already put in a playlist. So that's kind of cool that you're checking in tonight because I was just thinking about you and hoping things have been going well with your cooking channel that you're doing. And if you're using your own file, you would do something like this. As found in the file, write 0 to example. Stream my file, numbers.txt, my file.setf, ios underscore base scientific, my file, lesson 154.272.524 inline, my file.close, or for the non-ANSI folks, stream my file, numbers.txt, my file.setf, ios scientific, my file, lesson 154.272.524 inline, my file.close. Jen's Cooking said it's been going kind of slow, but my mom has fallen ill, so I've been trying to help her get back and forth to doctors. But I plus my hand. Oh, I hear you. Well, I'm so sorry to hear about your mom, but I'm very happy that she has you there helping her. And yeah, priority is definitely your mom, for sure. I'm sure people appreciate you doing whatever you can when you can, but seriously, priority is definitely your mom. So I'm glad that you're there for her. And trust me when I know what you're going through. I know what you're going through. Like my boyfriend, I help him. I make sure he's good. I'd be lost without him, so I do my best to help him with everything he has to go through. So, good. I'm glad you're there for your mom. That's awesome. So, when you run this code for writing to a file, the numbers.txt file will contain one of the following examples depending on your particular compiler and library. 1.154275E plus 005 or 1.542725E plus 05. Tip. Each of the iOS base flags exists both as a format specifier and as a manipulator. Don't worry about the precise differences for right now. Book 5, Chapter 5 explains the manipulators in detail. Therefore, you can, for example, use either of the following lines to set bool alpha. See out dot set f ios underscore base colon bool alpha. See out bool alpha. Remember, no, warning, we're talking only about the iOS underscore base flags here. The iOS flags do not coexist as manipulators. You can use these flags as manipulators only with an ANSI compliant library. Remember, if you use the manipulator form of a format specifier, don't put an inline at the end of the line unless you want an inline to print, as in this. See outbool alpha inline. Following is a rundown of the format flags available in both the ANSI compliant and non-ANSI compliant libraries. As mentioned earlier, you'd set these flags by calling setf, and you turn off a flag by either calling unsetf or, for some flags, by setting a different flag. For example, both of these turn off scientific mode. See out.unsetf ios underscore base colon scientific. See out.setf ios underscore base colon fixed. Jen's cooking said, yes, my mom is 7 pregnant. She has cancer, so it's a lot to take care of. Also, my main channel is my Curious channel, so I usually post on it before my cooking one. Oh, okay, cool. Yeah, for sure. Yeah, cancer is very scary stuff. Oh, I didn't realize you had a main channel too. That's cool. And also that your cooking wasn't your main. In the following list, we point out when you can set another flag to turn off a particular flag. One of these, bool alpha, is available only to you ANSI style folks. Remember, ANSI people must use iOS underscore base colon before each of these. Non-ANSI people must use iOS colon before each of these. You don't understand the colon. Effectively, it's just how effectively you're calling the thing, but in order to call the thing, you have to put the colon in. So the colon effectively means that you're calling a thing from this thing. So this is the thing. Class, that's the class. That's the class, and that's a member function from the class. So in order to get the member function, you have to list the colon. That's all that's saying. Bool alpha. That's the only. Setting this flag causes Boolean variables to write with the words true or false, or the equivalent words for your particular locale. Clearing this flag causes Boolean variables to write 0 for false or 1 for true. The default is for this flag to be cleared. Fixed. This flag specifies that, when possible, the output of floating point numbers will not appear in scientific notation. We say when possible because large numbers always appear in scientific notation, whether you specify scientific or fixed. A thing equals a variable? No, it's okay. So what happens is a member function is a set thing. It's not a variable. Oh, you're saying what I meant by a thing. Okay, so what I'm saying is, okay, let me try that again. So in this case, iOS underscore base is the class, and effectively you hit colon, that means to get the member variable. In this case, the Okay, I guess it's a memory. The point is, this particular, on the right side of the colon is the member variable. And on the left side, that's the class. So I guess it is a variable. The point is, the thing that is located on the right hand side of the colon is the member variable, and the thing that is located on the left hand side is the class. So I guess yes, but I guess I should be specific about which part of on which side of the colon. So in this case, the right side is scientific. On the right side of this, that's the member variable fixed. So if they had said iOS underscore base, and then instead of fixed it had been bool alpha, then that would be the member variable. But effectively, the member variable is already set with code. So what I was more saying is that it doesn't change. It's already coded what it's supposed to be. So effectively, you're just pulling that code to get the behavior. Okay, but Jen's cooking here. That's true. Or is it back? BK? I don't know. Anyway, Jen's cookie is here, and that's pretty awesome. But definitely hope your mom is doing better. Because cancer is definitely a lot to deal with. I know that for a fact. Oh. Sure, Curious is back. I see now. Randy says, okay, I kind of understand, but I never programmed past 5 pages of Google. Oh, okay. I feel like that was a joke, right? I feel like you got more time. Like, you definitely have more time coding professionally than I do, because I haven't coded professionally. Everything I've ever done is just for a class. Okay, so we were talking about fixed already. Oh gosh, there's so many. Oh. Okay, I'm going to close out this section and then my timer rings. So I'm going to close out this section and then I'm going to. What? Oh, I'm sorry for your loss. You're curious. Uh, Scientific. When you specify this flag, your floating point numbers always appear in scientific notation. Duck, spelled DEC. When you set this flag, your integers will appear as decimal numbers. To turn this off, you turn on a different base, either hex for hexadecimal or oct for octal. Huh? Jen's cooking is me sure curious? Hold on. Jen, did you just switch over to your other? YouTube? And I'm just missing that? Because that's something I would do. And also, you're welcome. Okay. Oh, you did. Okay. Thank you. Oh. I would go to both of your channels, but I don't know how to do that with my phone. So I'm gonna have to wait till the computer works out okay. Oh, okay. Thank you. Well, knowing the way my memory goes, you're gonna have to do that a few more times, but I'll eventually get it. If I had my computer available, which I don't yet, I could go to your channel and subscribe if I haven't already, but can't do that with my phone though. Okay. My idea says, that is so funny, Coded Pro. I mean, past what I do, I don't code perfect. All I've ever done is something I had to do for school. That's it. That's all I've ever had to do. Artie says they coded for work, but that's a side thing at work and better than the pros I worked. Oh, I see. Oh, okay. My apologies. Hope I didn't strike a nerve there. Uh, Hex, with this flag, all your integers appear in hexadecimal format. To turn this off, choose a different base, deck, or aught. Computer people like hexadecimal because it looks cool to see letters in your numbers. Aught. When you turn on this flag, your integers will appear in octal format. Oh, fun. Left. When you turn on this flag, all numbers will be left aligned with the width field. See setting the width and creating fields later in this chapter for your information on how to set the width. Right, with this flag, all your numbers will be right aligned with the width field. Show base. When you turn on this flag and print an integer, the integer will be preceded with a super special character that represents none other than the base. Decimal, hexadecimal, or octal. That can be good because the number 153 can represent 153 in decimal or 153 in hexadecimal, which is equivalent to 339 in decimal, or 153 in octal, which is equivalent to 107 in decimal. Yikes! Show point. With this flag, your floating point numbers have a decimal point, even if they happen to be whole numbers. That is, a floating point variable that contains 10.0 will print as 10, with a decimal point after it. Without this flag, it will just print as 10 with no decimal point. Show post, spelled POS. Normally, a negative, pause, okay. Normally, a negative number gets a minus sign before it, and a positive number gets no sign before it. But when you turn on this flag, each of your positive numbers will get a plus sign before it. Cool! Unit buff. This is for advanced people. When you turn this on, your output will flush after each output operation. In other words, the library will not accumulate a certain amount of output before writing it in batches. Instead, the library will write the output all out each time you use the insertion operator. Listen. Ryan Rodeo said you can do better than most. I mean, in theory, you've never seen my code though, so not sure. I guess we'll just have to see what you think after I get some coding in. Uppercase. When you write hexadecimal or scientific numbers, the various letters in the number will appear as uppercase. Thus, the letters A, B, C, D, E, and F will appear in capitals in a hexadecimal number, and the E representing the exponent in scientific notation will print as a capital E. When this is not set, you will get A, B, C, D, E, and F for hexadecimal numbers, and E for the exponent in scientific notation, and all of them are lowercase. Oh, Ryan Idea says, I've never seen your code, but have your senior thoughts. Oh, okay. Well, we'll see. Table 2-1 shows the manipulator forms of some flags. We're providing 3 columns in this table. First is a flag, then the manipulator to turn on the flag. Then comes the manipulator to turn off the flag. Yes, you need a way to turn it off. We coined a new word, demanipulator. Yeah, that sounds good. Remember, if you're pre-ANSI, you don't have access to these manipulators. Instead, you have to call setf. Going to sleep, but I'm almost done. I'm literally almost done. Hold on, I'll show you. Hold on. Right. Just this and that, and then I'm done. with the stream. So don't go anywhere. Table 2-1, using ANSI standard manipulators and demanipulators. Flag, bull alpha, manipulator, demanipulator. Okay, bull alpha, no bull alpha. Show base, no show base. Show point, no show point. Show pause, no show pause. Skip skip WS, no skip WS. Uppercase, no uppercase. Fixed, scientific, fixed. The scientific flag and fixed flag are opposites. Fixed turns off scientific and scientific turns off fixed. The default, if you don't specify either, is fixed. 6 manipulators aren't in table 2-1 because they don't have a demanipulator. Instead, they are three-way. Bases, deck, hex, and odd. Only one base can be active at a time. Activating a base automatically switches off the other bases. Alignments, internal, left, and right. Only one alignment can be active at a time. Activating an alignment automatically switches off the other alignments. And that is it. That is all for the C++ All-In-One For Dummies stream. Thank you so much for coming by, for checking out C++ All for Dummies time, especially thanks to Renardina, because I don't know anyone else besides me who's that much into C++ All for Dummies, or C++. So thank you. If you already went to sleep, I hope you didn't, because I was almost done, but oh well, I guess. I know I'm about to go to sleep myself right now. Thank you so much. Um, to you, Renardina. Good night to you, Renardina. Good night, Sure Curious. Thank you, I'm sure I will. Please also, good night to you. Sleep well to you also. And good night, Nightbot. I don't know what you do when you're not here, Nightbot, but if you do sleep, I hope it's enjoyable. And good night to anyone that I may have missed. That means Jen, who is here, but who's sure curious. And yeah, I'm very glad that you came by today. But yeah, so yeah. So thank you to you guys, and thank you to anyone who might come in the future to check this out. And whenever, wherever, however, whatever, just make the most of it. That's the most important part. Bye bye.